My name is Kashish. My roll number is Y13UC139.
Hello sir, my name is Kartik Kumar. My roll number is Y13UC137.
To present our real-time system project, which is weighted fair queue and start fair queue. We are implementing these algorithms in a simulator. So I'll first define weighted fair queue. Basically, weighted fair queue is a computer networking algorithm which schedules the packet and allows a guaranteed bandwidth service. So in weighted fair queue, every task is assigned a weight for the priority. So we'll calculate the finish time. So every finish time will take into account the weight. So every whichever weight will have have the highest weight will get the highest priority. So every task are scheduled on the increasing order of finish time. So how to calculate the finish time? So there is a formula for it. Every finish time will take into account the start time and start time. Start time is SQIK. SQIK is the start time, which is calculated and max of VRIK and FQI minus K minus 1. So RIK is equals to request time, means after how much time the next request of instance I is coming. Next request of instance of task I is coming. So and FQI minus K is finish time of instance K minus 1, means previous instance of the task I. What is that finish time, and we'll calculate the finish time according to that. And finish time is start time, which we have just defined, and QIK is quantum. For every task there is a instance of task I, there is a quantum defined. We have not defined the different quantum for in different instances, so we can ignore that subscript I. So we have taken default quantum as 1, and upon Wi is a weight of task I, which I defined earlier. Every task is assigned a weight. So according to that, we'll schedule the packets, and whichever task have instance of task has lowest finish time, virtual finish time, will be scheduled first. So this is weighted fair queue. And now start fair queue. Actually, the start fair queue was implemented to reduce the computation complexity of weighted fair queue. It is much simpler than weighted fair queue, because we only take into account the start time, and based on the start time only we'll schedule the task. So how to calculate the start time? It is same as weighted fair queue, which we calculated earlier. The start time, we defined the formula for start time as max of VRIK and FQIK minus 1. It is the same one. So whichever instance of task is having the lowest start time, that will be scheduled first. So now I would like to define take one example for weighted fair queue and define how it works. So this is a weighted fair queue example. In this we are taking two tasks, task 1 and task 2, and start time of both the tasks is 0, number of instances 3 and 5, and we have task 1 is having weight 3 and task 2 is having weight 1. So first we'll calculate the finish time of both the tasks. So finish time will be calculated as start time plus quantum upon weight. So finish time of task 1 is equals to start time is initially 0 plus quantum we are taking 1 as default, and by 3 is equals by 3, that is weight, so is equals to 1 by 3, and finish time of T2 is equals to initial start time is 0 and quantum is 1, and weight of T2 is 1, so 1 by 1 is equals to 1. Now we can see that finish time of T1 is less than finish time of T2, so we'll schedule T1 first. That is output order I have defined here. So T1 will be scheduled first. Now we'll again calculate, we will have to redefine the start time, and then according to that we'll calculate the finish time, and then we'll compare. So because only we have scheduled T1 first, so start time of T1 will be changed. So start time of T1 is equals to max of 0 plus 0.25. 0.25 is time period for request for after this time period, and the next request will come. So 0.25 comma, and last finish time last finish time was 1 by 3. So max of these is this is 1 by 3. So finish time of T1 is 1 by 3 plus and the same one, quantum and weight 1 by 3 is equals to 2 by 3. Now again and finish time of T2 will remain same as previous. So again we can see that finish time of T1 is less than finish time of T2. So we'll schedule T1 again. So here it is defined T1. Now again we'll calculate the start time. Start time for T1 is equals to max of 0.25 plus 0.25, because previously the request was coming as 0.25, and the next request will come at next 0.25. So 0.25 plus 0.25 we can take 1 by 2 it, and the previous finish time, which is 2 by 3. So max of it is 2 by 3, and the now finish time is equals to 2, and this one 2 by 3, and the same one quantum upon weight, which is equals to 1, and the finish time of T2 will remain same as previous. So it is also 1. Now we can schedule any of them. Let's say we'll schedule T2. Now that is written here, T2 will be scheduled. So now that start time of T2 start time and finish time of T2 will be changed. So I'll calculate that. Start time of T2 is equals to max of 0.75, because previously it was 0.5, and we'll add 0.25 more, so 0.75 and 1. So max of it is 1, and the finish time of T2 will be 1 plus the same one, quantum upon weight, which is 1 only, so which is 2. Finish time of T1 is 1. So again T1's finish time is less than T2 finish time, so we'll schedule T1 now which is written here. Now we can see that no instance of T1 is remaining, only the 4 instance of T2 is remaining. That will be scheduled because no instance of T1 is there, so only T2 is there. So we'll schedule all of them, T2 and T2 4 times, because 4 instances are remaining. So this is the example of weighted fair queue, how this is how it works. Thank you.
Now we will run our application and try to implement the explained example on our application. So basically our application is capable of demonstrating the scheduling of the two tasks. User need to pass the argument the arrival time, the packet length or the computation time, weight, regeneration time. By default the value of regeneration time is set to 0.25 and the value of quanta is set to 1. Now entering the values. Clicking on the proceed, as you can see in the output window is showing the start and the finishing time after every quanta, and both the resultant scheduling of both weighted fair queue and the start fair queue. Thank you.